Hi students, in this video I am going to explain the basic concepts of coordination compound, unit number 9. So first of all, have a look on the reduced syllabus. You have to study only the introductory part, type of ligand, coordination number, colors, then magnetic property, diamagnetic, paramagnetic, and shape. Shape, sp3 के लिए is tetrahedral and dsp2 के लिए is square planar and then d2sp3 and sp3 d2 के लिए octahedral. So these are the main type the shapes. So then you have to have a command on IUPAC nomenclature, then Werner's theory, valence bond theory, and crystal field theory. So this is the portion. You need not to study anything about the isomerism now. Geometrical, optical कुछ भी नहीं पढ़ना है, and application part भी आपको अभी delete कर दिया गया है. Now we'll first of all explain the basics of coordination compound. Coordination compound are compound in which the transition metal atom or transition metal line is bounded to number of anionic or neutral molecules which are called ligands. So coordination compound basically contains two type of valences. One is called primary valency and another is called secondary valency. This is what was the major achievement or discovery of the Werner's coordination theory. So Werner said that coordination compound two type the valency. The primary valency is ionizable and secondary valency is non-ionizable. So primary valency is the one which is found outside the coordination sphere, like in here K4 this is the counterine. Okay. It may be positively charged or it may be anion also. Okay. So here it is written these are satisfied by the negative ions. Sometime positive charge ions are also there which act as a primary valence. But secondary valencies are non-ionizable and these are satisfied by the negative ions or neutral molecules. So these are present inside the square bracket. So FeCN6 is present in the bracket here, you can see. So this square bracket is actually called the coordination sphere or coordination entity. And here cyanide is called the ligand and 6 is the coordination number. Suppose you are asked what is ligand, then ligand you should know, you should say that ligand is the species which form coordination bond with the central metal line. And what is coordination number? The coordination number is equal to number of ligand present in the coordination compound. And this square bracket, as I was telling, which is called as coordination sphere or coordination entity, inside this the secondary valency is present. So CN6 actually this is the secondary valence. Secondary valence is equal to 6. Primary valence is equal to the oxidation number and secondary valence is equal to the coordination number of the metal. So again I am clarifying this point. Now this ligand here, the ligand I was talking about. So ligand is basically of four types. One is monodentate ligand, another is didentate, polydentate and ambidentate ligand. In monodentate ligand only one atom is attached, so Cl negative and NH3 water, these are the monodentate ligand because it can ligate or it can ligate to the central metal line through only one donor site, because there is only one attachment site or one donor site is present. Didentate ligand, there are two atoms or two donor sites. There are only two didentate ligand in NCERT mentioned. One is C2O4 2 negative, which is oxalato, and ethane 1,2-diamine, which is written as EN in short also. And these are didentate ligand because it can form two bond with the central metal line. And polydentate ligand, the ligand which contains two atoms or attachment sites are called polydentate ligand. In simple words, I am again repeating, if the ligand is able to form two or more than two bonds with the central metal line, that is called polydentate ligand. EDTA4 negative is a liquid which is ethane 1,2-diamine tetraacetate, so it can form four bond with the central metal line, so it's a polydentate ligand. Ambidentate ligand is the species in which two donor sites are there but uses only one at a time. For example, NO2 का N when form bond with the central metal, this is called nitrito N. And if the O of the NO2 group form bond with the central metal line, then it is called nitrito O. Similarly, SCN negative. If the sulfur of the thiocyanate group form metal bond with the metal, then SCN negative is called thiocyanato. And if N form bond with the metal, then it is called isothiocyanato. So like this, ambidentate ligands can be described. Next is the chelate ligand. The chelate ligand means when didentate or polydentate ligands are present in a coordination compound, then the complex is said to be the chelate complex, and these ligands are called chelate ligand. So the chelate ligands may di or polydentate ligand is there, so it will use two or more donor atoms, okay, to bind to the central metal line. So ethane 1,2-diamine is one of the chelate ligands. Similarly, oxalatine can be also regarded as chelate ligand. Now I'm coming to the nomenclature part, which is one of the most crucial topic. So for example, you have this compound CONH3 So first step while naming the nomenclature you have to follow. First of all, you find the uh, charge on the oxidation number of the counter ion or primary valences which is present outside the bracket. So there are 3 chlorine outside the bracket, see 3 negative. It means this bracket CONH3 into 6, which is coordination sphere, it will contain 3 plus charge. Chlorine 3 minus, so the coordination box will contain 3 plus. So 3 plus means after this in the next step you have to find the oxidation number of the central metal line. Cobalt is the central metal line, so suppose the oxidation number of the cobalt is X and X plus NH3 is 6, so 6 ammonia is a neutral ligand, so 6 into 0, and the overall charge on the coordination sphere is plus 3, so the oxidation number of the cobalt will be plus 3. So this is the 2 steps, these are the prime steps. Find the oxidation number of the primary valence Cl negative, 3 negative, then you find the charge on the coordination sphere, 3 plus is the charge on this bracket, and then third step you find the oxidation number of the central metal line. Afterwards you will apply the rule. Now rule number 1, cation is named first, but there is no cation as a counter ion present here. There is anion is present, so anion is always named at the last. Here you can see chloride is named at the last. Now second step is have a look on the ligands. If it is homoleptic ligand, only one type of ligand is there, no issue. But if it is heteroleptic like complex in which more than one type of ligand are present, then you have to arrange these ligand in alphabetic order. Alphabetically पहले कौन आता है ये देखना है. So after that you start doing the naming, and if the ligand is anionic like Cl negative, then NO2 negative, Cn negative, these anionic ligands are suffixed with O, इनके एंड में O आएगा. Cl negative को हम क्लोरिडो लिखेंगे, Br negative ब्रोमिडो, I negative आइडिडो, NO2 negative नाइट्रिटो, okay, maybe nitrito or nitrito, and depending upon the type of ambidentate ligand. So similarly you have to remember that if ligand is negatively charged, like oxalate is there, C2O4 2 negative, oxalato, so these negative anionic ligand are suffixed with O. This thing is very much clear. Now if the ligand is positively charged or neutral, like NH3 is a neutral, amine, A-double-M-I-N-E, spelling will be A-double-M-I-N-E. In organic chemistry we use single M for amine. Here double M, this is the inorganic chemistry. Then water is there, you have to use aqua. If CO is there, you have to use carbonyl. Like this it goes. Now here 6 ammonia is there in this complex, so you will write hexaamine. After that cobalt, this is the central metal line, cobalt, and oxidation number of the cobalt is plus 3. and then the your this counter ion, which is Cl, so chloride. Okay, so you don't write trichloride because it has already been adjusted with the charge on the coordination sphere. Now you have to remember one thing: if the charge on the coordination sphere is negative, okay, then the metal name is suffixed with 8. अभी चार्ज जो है कोऑर्डिनेशन स्फीयर पे ब्रैकेट के ऊपर 3 प्लस है, सो मेटल नेम इज रिटन एज सच. अगर यहाँ पे 3 नेगेटिव होता तो मेटल नेम इज सफिक्स विद 8. कोबाल्ट का कोबाल्टेट, आयरन का फिरेट, एजी का आर्जेंटेट, पीटी का प्लेटिनेट, पीडी पैलेडियम का पैलेडेट, लाइक दिस इट गोज. निकल का निकलेट, कॉपर का क्यूपरेट. If the charge on the bracket or charge on the coordination sphere is negatively charged, so metal name is named suffixed with 8, ATE. This you remember, okay. Now there is a second complex K3Cr C2O4 thrice. Now potassium is the rule number 1. Potassium is the counter ion, cation, so cation is named first, potassium. Now there are 3 ligands, so the name is written tri, and oxalate is there, so oxalate anionic ligand है तो oxalato लिखा जाएगा, so the trioxalato. Then coordination sphere contains charge 3 negative. here bracket के ऊपर 3 negative है because potassium is 3 plus, so bracket के ऊपर 3 negative लगेगा. तो नेगेटिवली चार्ज अगर हो कोऑर्डिनेशन स्फीयर, then the metal name is suffixed with 8. that is why the name chromate is coming. so afterward the oxidation state of the chromium, which is 3. और क्रोमियम की ऑक्सीडेशन स्टेट 3 कैसे निकाली? लेट अस सपोज क्रोमियम की ऑक्सीडेशन नंबर इज x, oxalate is -2, so -2 into 3 is -6, and this is equal to charge on the coordination sphere is -3. So here you can find after solving the coordination number that charge on the chromium is coming +3. so this is what we are writing here, +3. ZnOH4 2 negative, so there is no counter ion mentioned here, okay, but it is there, but it is in the aqueous medium, it is not shown here. so tetrahydroxo, okay, tetrahydroxo, OH is a negatively charged species, so hydroxide नहीं लिखा, hydroxo लिखा, tetrahydroxo. coordination sphere contains negative charge, so zincate, not zinc, okay. then 2 is the oxidation number of the central metal ion, x -4 is equal to -2, x is equal to +2, like that. so this is, here you remember one important point बच्चा, कि if in place of C2O4 ऑक्सलेट की जगह अगर यहाँ पे EN होता, इथेन 1,2 डायमाइन, तो यहाँ पे आप 3 EN की जगह ट्रिस ऑक्सालेटो लिखते, ट्राई ऑक्सालेटो नहीं लिखते. वाई? बिकॉज EN में हाइड्रोकार्बन इज देयर. EN का फॉर्मूला इज CH2, NH2, then CH2 and NH2. so this is a didentate ligand. so यहाँ देख रहे हैं आप, this is the hydrocarbon. so carbon whenever is there, and the didentate name should be prefixed with the bis, tris or tetra case depending upon the number of ligand present. अभी 3 EN होगा तो ट्रिस इथेन 1,2 डायमाइन लिखा जाएगा. so this is the thing. Now I am coming to the valence bond theory. What is valence bond theory? Valence bond theory simply says that the bonding between metal and ligand is the coordinate bond. This, see, ligand contains like excess electron, extra electron is there. So ligand like shares its electron with the empty orbital of the central, empty d orbital of the central metal ion, and form coordinate bond. This is valence bond theory, simple. so valence bond theory, here we discuss two type of complex. One is inner orbital complex and another one is outer orbital complex. Inner orbital complex, in this NCERT we study two type of hybridization, D2sp3 and dsp2. When hybridization is D2sp3, then the structure is octahedral, and when hybridization is dsp2, it is square planar. This is very much clear, we know all. And in outer orbital complex, there are two type of hybridization. One is sp3d2 and another is sp3. When hybridization is sp3d2, the structure remains same octahedral, and sp3 then the structure is tetrahedral. Now we have to understand on what basis we come to know that which species will form inner orbital and which will form outer orbital complex. When this VBT was discovered that time scientists were not aware of the spectrochemical series. उनको field strength ligands के field strength के बारे में मालूम नहीं था, लेकिन वो सभी complexes, all those complexes which form inner orbital complex they contain strong field ligand. And in exam there are only three types of the strong field ligand question comes from. One is CO carbonyl, another is CN cyanide, and third one is ammonia NH3. अगर आपको किसी भी कोऑर्डिनेशन सफेयर में आपको ये तीन लाइगेंड दिखते हैं तो आपको इसको इनर ऑर्बिटल कॉम्प्लेक्स कर देना है. सिंपल सा फंडा आपको बता रहे हैं. सो यू सी FeCN263 नेगेटिव साइनाइड इज देयर, सो इट विल फॉर्म इनर ऑर्बिटल कॉम्प्लेक्स. तो इनर ऑर्बिटल कॉम्प्लेक्स में डी देखो अंदर वाला पहले आया है, इन आउटर ऑर्बिटल कॉम्प्लेक्स डी बाद में लिखा गया है. नो इनर ऑर्बिटल कॉम्प्लेक्स करते क्या है, ये इनकी फील्ड स्ट्रेंथ स्ट्रांग होती है, सो इट काज द पेयरिंग ऑफ द डी ऑर्बिटल. इनर जो डी ऑर्बिटल होती है उनकी पेयरिंग कर देते हैं और वहाँ पे वो इलेक्ट्रॉन्स जब पेयर हो जाएंगे तो डी ऑर्बिटल में खाली जगह निकल जाती है, उसमें फिर वो लाइगेंड अपने इलेक्ट्रॉन्स डाल देता है एंड हेंस द स्पिन गेट्स लो. क्योंकि जब पेयरिंग हो जाएगी तो वो क्लॉकवाइज एंड एंटी क्लॉकवाइज प्लस ऑफ एंड माइनस ऑफ जो स्पिन होते हैं इलेक्ट्रॉन के वो कैंसिल आउट हो जाएंगे और स्पिन बिकम्स लो. ओके, and when pairing occurs then dimagnetic type of complex is formed. This is also very much clear. Automatically all these things will come in your mind if you know this point कि ये तीन is the strong field ligand and where these three ligands are formed inner orbital complex will be formed. Now for a hint for the outer orbital complex is that if you find halogen in any coordination compound or water then definitely it will form outer orbital complex because X mane halogen means weak field ligand. So weak field ligand forms outer orbital complex. So here pairing do not occur, so it will be unpaired, there will be unpaired electrons, so paramagnetic, and high spin. Low spin nahi hoga because the unpaired electrons do not cancel out, so spin will be high. So these are the points that you have to have a look on the type of ligand. Halogen, weak field ligand, outer orbital complex. CO, CN, ammonia, strong field ligand, inner orbital complex. Now here again you can see the Ni CN4 2 negative tetracyanidoniculate 2 और tetracyanoniculate 2 दोनों नाम सही है. So here the type of complex formed is low spin complex and it is the inner orbital complex. Why it is forming inner orbital complex? But NiCl4 2 negative, why it is forming like paramagnetic complex या high spin complex? Question can be asked. Question can be asked in many way कि NiCN4 का स्ट्रक्चर स्क्वायर प्लेनर क्यों होता है, इसका टेट्राहेड्रल क्यों होता है, ये डायमैग्नेटिक क्यों होता है और ये वाला पैरामैग्नेटिक क्यों होता है, NiCN4 वाला लो स्पिन कॉम्प्लेक्स क्यों बनाता है और ये वाला हाई स्पिन कॉम्प्लेक्स क्यों बनाता है. इन सभी सवालों का एक ही जवाब है दैट साइनाइड इज अ स्ट्रॉन्ग फील्ड लीगैंड, सो इट विल काज द पेयरिंग ऑफ द इनर निकल डी ऑर्बिटल, सो द हाइब्रिडाइजेशन बिकम्स DsP2, so it forms low spin complex. Okay, so that is why the complex is diamagnetic. And in NiCl4 2 negative, here Cl is the weak field ligand, so electron will remain unpaired, so it will form paramagnetic complex, it will form high spin complex. Hybridization will become sp3, so the structure will be tetrahedral. So you have to give attention only on the ligand. Ligand strong to inner orbital complex, ligand weak to outer orbital complex. Now when the crystal field theory came, then scientists came to know about the spectrochemical series. So spectrochemical series is the discovery at the time of CFT. So earlier the people were not able to like understand why few compounds form like sp(d2), dsp2 and square planar complex and why few forms tetrahedral complex है ना, कुछ inner orbital कुछ outer orbital क्यों बनाते हैं. So CFT described that arrange the ligand in the increasing order of the field strength, and this was the field strength. So you see all the halogens, these are negatively charged species, that is on the left side of the series, and all the ligands like ammonia, cyanide and CO, which are lying on the right side, these are the strong field ligand. Okay, so this is the like ascending order or arrangement of the ligand according to the field strength, which is called spectrochemical series. If for the competitive exam you want to remember this series, you can remember like this: ibrothio, class, fox, FOOH is the hydroxy, and ox means oxalato. Okay, then water NCS, EDTA, ammonia. Then ENCNCO. Here cramming will be required, but ibrothio, class, fox, this is the mnemonic. Then water NCS, EDTA, ammonia, and ENCNCO, this you can cram. Okay, CO is the strongest field ligand. Now what crystal field theory says and how it is different from the VBT. VBT used to say that bonding between the ligand and the metal is coordinate bond, but CFT says that the bonding between the ligand and the metal is not coordinate, it is the ionic bond, it is the electrostatic bond. It says that when this is the d orbital of the central metal line, and it says that when the ligand approaches the metal, then its energy of the d orbital increases. Okay, and when ligand comes so closer that it form ionic bond or electrostatic bond, then d orbital gets split into two sets, and higher set is called Eg and lower set is called T2G. In the higher set, dz square and dx square minus y square orbitals are there, this is the Eg, and the lower set contain dxy, dyz and dzx, these three orbitals of the d orbital, and this is the T2G type. And the energy difference between these higher set and lower set Eg and T2G is represented by delta naught, which is crystal field stabilization energy for O for octahedral complexes. And the upper one from the barycenter, this center line is the barycenter, and upper line the Eg has the energy 3 by 5 delta naught, and T2G has energy decrease in energy by 2 by 5 delta naught. So this much you should remember. Now in exam how the question is asked, before that I will tell you that for the tetrahedral complexes this sequence of splitting is reversed. ऊपर रहता है dxy, yz and zx, and this is called T2. Okay, and the lower contains dz square and dx square minus y square, these two orbital, and this is called E. यहाँ mistake है, not Eg but E, and upper one is called only T2. And here in place of delta naught you write delta T. T stands for tetrahedral complexes. So this is the only difference in the splitting. And now one important point is written here: strong field ligand, high delta naught. Okay, and hence form low spin complexes. If the field strength is strong, so it will form low spin complex. वो फंडा इधर भी सेम ही है जैसे हम VBT में पढ़ाते थे. वीक फील्ड लाइगेंड है, सो इट विल फॉर्म हाई स्पिन कॉम्प्लेक्स, क्योंकि पेयरिंग नहीं करा पाएगा ना ये, इसलिए हाई स्पिन कॉम्प्लेक्स बनाएगा. So this is about the crystal field theory. Now what type of question are asked in the crystal field theory, that I will explain later on. But before that I am going to explain now the synergic bonding. You just remember one thing, that metals contain empty orbital and few filled orbital. Here M stands for metal, and this pair of electron represents filled orbital of the metal. Similarly, CO is the ligand. Ligand also contains few empty orbital and few filled orbital. When filled orbital of the metal form bonding with the empty orbital of the ligand, and when filled orbital of the ligand form bonding with the empty orbital of the metal, then this two-way type of bonding which is formed is called the synergic bonding. Okay, so these are found in the organometallic compound. Okay, so in which both have sigma and pi bonds. So the MCO bond is the sigma bond, and MCO from metal to ligand is the pi bond or back bond. So this 2 point you need to remember. Next is a question is asked in coordination compound on the color also. Now you will be asked ki this hexa aqua nickel 2 shows color hexacyanidofurate 2 shows color, hexa aqua iron 2 shows color. Why? But other complex उसके against कोई दिया होगा, वो color क्यों नहीं show करता है, ये क्यों show करता है? So you have to explain like this कि भैया it contains unpaired electrons. You have to show, you have to write the electronic configuration. Nickel atomic number is 28, so configuration will be argon 3d4 as 18 2 20 और 8 28. Now here the oxidation number of the nickel in this complex is plus 2, so 2 electron will go and 3d8 it will become. 3d8 means how many unpaired electron will be there? 1 2 3 4 5 6 7 8. So nickel in plus 2 oxidation state, nickel in plus 2 oxidation state has 2 unpaired electrons. So because of this unpaired electron dd transition occurs, मतलब कि lower T2g से higher Eg में electrons jump करता है upon gaining the energy from the radiation, and when it fall back then it gives color. It's a simple it's a simple funda which we studied in the D block complex also. Okay, in D block also we studied. So this was all about the major broad line points, the coordination compounds, and for the exercise questions from the coordination compounds, you will have to watch my next video. So till I prepare my next video, I want you all to watch this video. Stay fit, stay fine. Thank you.